guys, welcome to our channel today. Yeah, I'm recording. Usually I record in fourth period, but I figured I would record in sixth today. Okay. All right, so welcome to Northridge's Sterling sixth period amazing class of amazingness. Here we go. Yeah. How you doing? Okay. Today we are going to go over while loops. So here it goes. All right. So with while loops, basically there's a condition that has to be true, right? Just like an if statement. Like when we type the actual while loop out, you guys are gonna be like, holy crap, it's just an if statement, except it says while. And that's really true. So what we're going to start off with is we need a variable to pivot our while loop around. We're going to use int I. I'm going to initialize as 0 because I know this is coming. Okay, so this is just a little advice for you guys. Don't use I or N, basically, as variable names because those are counters. And it's not that, there's nothing that's going to tell you you can't do it, but just like, it's good form, right? To use I as a counter and N as a counter, and to not use it in other places. Okay, so this is what we're gonna do. So this is our while loop. So this is gonna look very familiar to your if statement, except it's while. And let's go while I is less than, let's do 100. While I is less than 100, and I'm going to put my curly brackets, right, because we have to have our bucket for what's going to repeat. Anything between this curly bracket and this curly bracket is going to repeat every time the while loop runs. Okay, so let's go system.out.print ln, and then let's just print I. Okay. So if I were to run this, what would happen? Crap. Whoa, look at my little thing. Look how fast it's going up. Oh, shoot. Get down to the bottom. Oh, I made it back down to the bottom. Yay! It's still crap. Okay, so what's going on, guys, is we've actually created what's called an infinite loop, and you are going to make a whole bunch of these. This is a loop that cannot exit. So be careful. Some infinite loops are actually crash your computer. This one won't. It's just going to print zeros for as long as I give my computer electricity. To stop it, all you have to do is there's this little red button right here. Click that, and it'll kill the program. Okay, build stopped. Okay, if you come here, and if you go to here, and we go here. Okay, so what's happened is if I never adjusts, okay, so I never adjust, how is it ever going to escape out of the loop? It's not, it never can, right? So what we have to do is we have to make a statement that will adjust I. So let's say we wanted to make something that counted from 0 to 100. If we went I equals I plus 1, right? So what that's going to do is that's going to add 1, take whatever value is currently in I, add 1 to it, and then take that value and store it back in I, okay? Okay. So what we have is if I run this, what will happen now? What's your prediction? So it'll count to 99? Hey, it did. Woo! Why did it not count to 100, guys? Because it's less than 100. If I take this and go here and go less than or equal to, will it go to 100? Yeah. Run file. Bam. 100. Woo! Right here. I just added that equal sign right there. Okay, so do you guys remember how beginning of the year we talked about programmers are lazy people? Okay, look at this, right? So I'm going to even do this the shortest possible way. That's a valid statement, right? So even if I do this the shortest possible way, look how many characters I have to type. It's like I equals I. That's 3, 4, 5. Everything has a semicolon, so I don't count that. But I have to type like 5 whole characters. That's like such a pain in the butt. So somebody had a brilliant idea. You could go I plus plus. What that'll do, I plus plus simply adds 1 to whatever is currently an I. It's called incrementing, right? So it means to take something up by 1. You won't use it for a while, but you just put this in your back pocket. You can also do I minus minus like that. And it'll go down by 1. Okay? So if I just go I plus plus, like that, now this should give us the same output except for with less code. Yay! Less code's always better. Well, almost always. Okay? So now we have this thing that will run, and it's going to be awesome, right? But, quite frankly, counting is not super useful. So let's do this. Num. Actually, let's go binary num equals, let's start with 1. Binary num, oh crap, I forgot to say int. Oops. I swore I typed int in my head. So what we're going to do, so if we have binary num equals 1, and let's come here and let's go, let's do binary num equals binary num times 2. And then what if we output that, and we just output binary num? Okay, what we have created is a program that will do what, Caden? What do you think? What do you think this is going to do when I run it? Which is what happens in the binary number system, you guys. So the binary number system basically is you take the number, you double it, that's the next number. So you have 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, right? I mean, 5096, like it just keeps going up, right? So if I run this, it should count the binary numbers for us. Mine is a whole bunch of zeros. Drake says scroll up. We've hit a problem. So it turns out that Java, with their 8-bit integers, can only count up to about 2 billion before it starts freaking out. So what's happened is this number is as close as it can do with memory overflow, and then it gets so big that the number can't be comprehended by Java. So it just starts going to 0. So clearly we cannot run this 100 times, right? But we could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 16 would be here. So we could go to about 30. Let's try that. So while I is less than or equal to 30, right? Let's try running it again. That's better. Except for that last one stinks, right? So let's just do while I is less than 30. That'll work. And that should give us the last good number. Okay, there we go. All right, so that works, doesn't it? Okay. Why don't I just change it to a double? It kind of works. We'll talk about why that doesn't work later. It kind of works. Okay. We don't have to just check I here though, if we don't want, right? We could do binary num. Binary num, while binary num is less than 2, while binary num is less than 2 billion. Right, so now the while loop should exit once it gets, oh shoot. I have no idea on that one. Did it do anything at the top? Oh, it did, it ran it. Oh, was that gonna run that to be 2 freaking billion? Wow, binary num. Oh. I may have put too many in there. It's never going to be less, yeah. It's never going to be, do you guys realize? It's never going to be greater than 2 billion because it errors out right before it gets there. So it's never going to run it. So that's interesting. I like that. So this one should work. Yeah, because it's trying to get, it's going to run the loop until binary num is greater than 2 billion, right? But if it can never be greater than 2 billion, that's a problem. So, what we've found is an error. But what kind of error is that? Do you guys remember? Is it a syntax error? Is it a user error? Whose fault is this particular error? No. Not user. The programmer is what error? When the programmer makes a mistake, what kind of error is it? It's not a user error because user error is the end person, not the programmer. It's a logic error, right? It means your logic is jacked up. So my logic, I was making the assumption that at some point it could be greater than 2 billion, but it can't. The way the memory allocation works. Okay, all right. So what I want you guys to take from today, right? While loops, just like if statements, right? Very similar, but instead of just checking once, it'll run as many times you want it to, okay? Checks it, or 1 billion times. Right, yeah? Okay, so we can run these 1 billion times if we feel like it, okay? And then incrementing. Just commit those two to memory for today, your binary number, your while loop, and your incrementing, okay? So we have that. If you have questions, make sure you ask me. Anything, Austin?
This person is the flag thing.
Okay. Oh, no, not flag questions, Austin. Not individual program questions. Savannah? Yeah. Yes. That we'll add that to what you guys can do into assignments. So I didn't want to throw too much into one day, but yeah, you can totally do that. What Savannah is saying is that if you add a plus equal or a times equal or a minus equal right here, it'll actually kind of do the same thing. So it's, yes, you can completely do that. Okay? Micah? Why hasn't the viewer, so guys, don't forget to smash the like button. Support your favorite content providers. Comment below. Actually, I think I have comments turned off for these, so. Yeah. Yeah, I don't want to know what you guys think of me, so it's okay. I don't need comments. But you can hit the like button. And you can hit subscribe. And you can check out my Twitch channel.
Wait a second.
I'm a little interested to hear what that sounds like on the actual video. Okay. All right, you guys good? Thank you for joining Bits. If 8 bits is a byte, what's 8 bitners? we go. All right.